I'd like to invite up our first speaker for today, Lukas Hartmann. Lukas is well known in the open hardware community for a daring project, if I might say, to build a fully open laptop. And if I'm not mistaken, this might actually be what he is presenting on. So please give a warm round of applause for Lukas Hartmann.
Okay, it works. Hi, everyone. I'm Lukas Hartmann. I run MNT Research, and thanks for having me here this morning. It's a big honor. Yeah, my talk is how KiCad enables the open hardware future. And yeah, MNT Research, we are a small electronics manufacturer that started out at home at the kitchen table. But since 2019, we work in a dedicated studio space in Berlin, Friedenau. This is part of the team at a different event. It's not our studio. We are probably best known for our open hardware laptops, the MNT family, MNT Reform family, but not only. We started out with a retro computer product, a graphics and network card for the Commodore Amiga computer. This is the original repo, I think my first KiCad repo on the internet. That was late 2015, where I started to use KiCad almost 9 years ago. I remember I still had trouble soldering SMD chips by hand then. I was getting used to lead-free solder, flux, and so on. I had a full-time day job in software development, and my then partner, Greta, helped me assemble and ship FPGA graphics cards from home that I developed because I was very bored at that job. It was also a time where there was still a big fab lab in Berlin, funded by Otto Bock, as far as I know. And they had all kinds of exciting 3D printers, laser cutters, and CNC machines. It was a really big space. All of this was quite new to me back then, and some people invited me over, and I kind of got to hang out there. I only knew 3D printers like the RepRap from the internet, but hadn't really used one yet, except one at SIGGRAPH conference in Canada. Yeah, you could also like solder there. People were doing fabric, textile stuff, and so on. And Chinese online services that could fabricate your PCB designs for a small price and in a short time became available. Around 2017, I was fed up with Apple making my MacBook obsolete through software updates and had the impossible idea to create a laptop from scratch and started working on it with the industrial designer Anna Dantas that I met in the context of Fab Lab. Yeah, this website is still up. We published an article back then about the design process of that first prototype. Our first prototypes were really basic, and we tried to make as many parts as we could from scratch, even 3D printed keycaps. Yeah, take a look. Yeah, here are resin printed keycaps. This morphed into more and more usable versions of the laptop that I'm using to give this presentation today, the MNT Reform. This is the beta version. 13 of these were made by hand. Yeah, and this is the MNT Reform as it was released on CrowdSupply in 2020. From the Amiga experiments, I felt like I had enough experience to create a keyboard and then a motherboard for this laptop, of course in KiCad. This is the keyboard. These pictures are already from a more evolved version of the devices. This is the motherboard, version 2.5, done in KiCad. Of course, our laptop also had to have a trackball, which turned out to be quite popular. This is the back side. But you could also drop in a trackpad instead if you wanted. Back in 2017, I had a distinct feeling that there was a chance for a shift in the means of production of electronic products, like computers that were totally open, and especially products that could be reproduced by makers in a decentralized way instead of corporate industrial processes, like you had to have a big factory. Would you download a laptop? I would. Of course, there was already a movement underway that understood this, which is open source hardware. There was already an open hardware computer platform crowdfunded in 2014, the Novena by Bunny and Xobs. This is a screenshot from the crowd supply website that's still online. The Novena was a great inspiration for me, but the real wooden laptop version of it was more like an expensive and beautiful art piece, and it used an off-the-shelf ThinkPad keyboard. Also, they didn't use KiCad, but the proprietary Altium software for PCB design. So our goal was to make a usable laptop with as many parts as possible, designed using free and open source software, and with as many parts as possible, either reproducible with widely available machines, or the parts themselves widely available, or that you at least could use substitutes for everything. And also, very importantly, we wanted others on the internet to be able to participate and improve the design in an open source process. This reform wasn't made by us, but by Jacqueline in Australia from our design files, and with customizations like a split keyboard and USB-C charging, which was possible because all the design files are on the internet. As far as I know, this is the first case of an open hardware laptop being reproduced independently, which was an awesome validation of the whole idea. Fast forward 7 years to now, we've shipped 2 major open hardware laptop models with total sales approaching 1,500 units. There's a growing community of Reform users that help each other and participate in software, firmware, and hardware improvements. We still design at a kitchen table, but it's the one in our studio now. And we participate in events like the Chaos Communication Camp and Congress, where people can try the devices and give feedback. We still make Amiga graphics cards. Here's Henri doing some final assembly on them. And here's Greta picking and placing a Pocket Reform motherboard with the help of KiCad iBomb plugin that we use for assembly. Here's Liaison testing Pocket Reforms before shipping. So we also use our own computers in the lab, or prototypes of them. We're constantly assembling, testing, and shipping laptops. And our dog Tina is taking care of that. We've also developed a range of upgrades and peripherals for the laptops, like a standalone version of the keyboard, now with RGB. And there's also a camera with electronics contributed by F. Schneider. One core idea of the MNT Reform family is that the designs are modular. The processor and memory reside on a card that plugs into a DIMM connector. Can I show this here? Yeah, so that one. And all the input devices are internal USB modules. These 2 modules are completely custom designs. On the left, with the Kintex 7 FPGA, done by me in KiCad. On the right, a Layerscape LS1028A module done by a company called RBZ in Altium. But at least it's also open source. But also adapting other module form factors like CM4 proved incredibly useful, so that you can use for example, the Banana Pi CM4 with MLogic A311D or the Raspberry Pi CM4 in the laptop as your processor. So you don't have to throw your laptop away to upgrade to a new generation of performance. For example, we now ship the Rockchip RK3588 processor that's around 5 times as fast as the IMX8M we started with. And you can plug that into the original model as an upgrade. So that's what's running in here at the moment. This adapter for the Firefly RK3588 module was designed in KiCad, of course. Next to this 13-inch laptop, we also launched a 7-inch mini laptop that supports the same modularity, the MNT Pocket Reform on the left. The Pocket Reform is a cuter version of Reform, targeted at mobile writing that supports a cellular modem. Yeah, that's what it looks like. That's the motherboard. It's tiny. Here are 2 revisions of the Pocket Reform motherboard. As you can see, it's quite small. By now, you should be able to guess which software I used for designing it. And we're at the moment polishing the design of a next generation 13-inch laptop called MNT Reform Next, where we shrink it to 2.6 centimeter thickness. Still not an ultrabook, but much better. And where the motherboard is much more modularized. Yeah, here's a render. And here are various iterations of the prototype that we're currently working on. The shell in this one is 3D printed here, but the final version will be milled from aluminum. Yeah, here's with upper shell parts removed, where you can see that the layout is very different now. The motherboard is split up into multiple specialized PCBs instead of being monolithic. So you can see there's just a ton of little connectors here, internal connectors instead of metal ones. And this is how it looks like in KiCad. There are up to 3 port farms that are separate PCBs. This is a very rough in development stage here. And user serviceable battery packs now have their own monitoring electronics integrated. Here is the right port board with USB and HDMI ports. But you could, of course, totally customize this, because you can download this file, change the ports how you like them, get them made at JLC, PCBWay, whatever, and plug them into your laptop. This is how it looks like in KiCad. So there's a lot of diff pairs, but otherwise manageable. Here's the left port board with more USB, Ethernet, SD card, and headset jack. And that's how it looks like. And this is the battery pack controller, which has tabs to connect to 18650 cells directly on the back. This design is contributed by Alan Eisendler, of course, also done in KiCad. I sound like a broken record by now. And this is the prototype battery pack with some handmade cables. So you can see it's terminated by these PCBs at both ends now. And the laptop can fit 8 batteries, but also works with half of them. Yeah, you can follow the development of MNT Reform Next now on CrowdSupply, but you can also already browse the Git repository, which already has all the KiCad projects, because we publish everything also while we are still developing it. I've upgraded through many versions of KiCad in those years and still use it all the time for all of the electronics, and it's getting better all the time. I'm also happy to see many other open hardware projects using KiCad nowadays. For example, Tangara, a portable music player, and throwback to the early iPod with a click wheel. Colibri Halo 90 sound reactive LED earrings. There are many LEDs on this one. Glasgow Digital Interface Explorer, universal tool for exploring interfaces. Olimex Terrace 1, another open hardware laptop, around for quite a long time already. Winterbloom Eurorack modules for analog synthesizers, beautiful. Watchy and e-ink watch. FOMO, a tiny FPGA board that fits in a USB port. Yeah, this is really small. The keyboard Featherwing by Solar Party, which reuses BlackBerry keyboards. They're here today, I saw outside with a lot of stuff. Lumen PNP, a complete pick-and-place machine for assembling electronics. And so on. Most of these have PCBs licensed under the CERN OHL, which is also a hugely influential license for open hardware. And if I could have a wish for the future of KiCad, it would be more features for collaboration, like file formats or helper tools for merging changes to the same designs by different people. At the moment, we do this manually. Yeah, thank you. In the end, I can't overstate the importance of KiCad's existence for enabling the world of open electronics. So a big thank you for developing it. And I hope we'll see many more everyday devices being designed as open hardware using KiCad. Thanks.
Lukas, thank you very much. I assume that when you started designing the laptop, that you might have had some problems with heat dissipation, didn't you? Or can you talk a little bit about that?
Which version do you mean? Like in the very beginning, the old versions, or right now?
Yeah, I never used it. I was just curious if you encountered problems with heat distribution.
Yeah, so what you can maybe notice or not, like most people don't notice at the first, like at the beginning, there is no fan, like the devices are fanless. And we had a fan in the first beta versions and it was super annoying. And some people suggested just put a huge aluminum heatsink in there, and we did that. And that worked out also because we have a very chunky metal box for the laptop. And you can see here on mine, for the RK3588, we now have a copper heatsink, custom copper heatsink in there, which is a big slab. So it works out. And in general, I would say we benefit by ARM processors being, in general, more power efficient than the then available, because it's changing also now, but then Intel had a reputation for running very hot. And we sacrificed some performance for cooler processors here.
Cool, thank you. So are there any other questions from the room? All right. Now where do I go first? Well, I don't have to walk so far.
Thank you. Your bottom is open, so it's transparent. Did you take it on a plane like this, and did you have some issues with it?
Yes. So yeah, you mean this also? These could look suspicious. So yes, I took it on a plane, and I was once then interrogated by German police, but they were very excited about the devices. I said also, one of them was like a Pocket Reform prototype, and it looked really like prototype-y. And they just wanted me to like start it up and then there was like the penguins popping up from Linux, and the police person was like, ah, this is Linux, I know that. So, all right, you're good to go. And they said like, okay, next time just talk to security first. Just tell them that you have this, like, don't just drop it in the box. And next time I went with the plane, I did that. I said, like, here I have a unusual computer. Is it okay? And they were like, sure. So no further problems. But the Reform Next won't have a transparent, it will look very like, you won't notice it. So it's, yeah, the next one is camouflaged.
My question is about the USB internal routing. Are there any bottleneck problems for the video, for example, speed of the USB connection?
I wouldn't say electrically. I mean, we don't have the equipment for like really measuring multi-gigahertz stuff. But I would say the limits are more in the SoCs. So that they, for example, if you saturate USB 3, that it couldn't process the video and then it would start dropping frames or something. But in general, it has been much more friendly than I expected, the physics, let's say.
Quick question. How do you handle ECAD, MCAD, co-design, like both creating the individual components and also checking how it fits in the device, like the PCBs? And can you use open source software for that, or do you have to use closed source?
That is an excellent question. So I use FreeCAD for that. The design of the case is not done in FreeCAD yet, but in Fusion, but I don't use that. So our designer uses it, and she sends me step files, and I load everything into FreeCAD. And also, it has been really useful to make sure that there's 3D models in KiCad everywhere for everything. It is so helpful also for checking that the part actually fits the footprint. So it's a good double check for that. And then I manually check interference, like 3D interference in FreeCAD. And there's a lot of churn there, but some people told me to use KiCad Step Up, which I haven't tried yet, I have to say. So I probably will save me some time, like updating the files. Like if you load a PCB into FreeCAD, that it would still stay in the same spot and you don't have to move it, like load it and move it again in the same place and so on. And I use clipping plane a lot in FreeCAD to cut, like to scan through the assembly and see if there's any like interference. And we also use 3D printing then a lot to just, you know, print everything, put it together, see if it still closes. Yeah.
Hi. Do you have like a custom test jig to verify the devices?
No. So not yet. It's one of the things we really need to do. So in the last batch of like the Pocket Reform, we ordered 750 keyboards from PCBWay, and so far more than 50 are broken because the RP2040 just has broken GPIOs, and we don't know how that happened. So we don't yet employ any end-of-line testing at the PCB assembly company, and we really need to change that next. So far, we have then relied on manual rework. But yeah, it's getting now to a point where to achieve some more velocity, we have to do a lot of, you know, specialized jigs and automation.
What's the thing that annoys you most about KiCad?
Oh, good question. So there was a thing recently that really, I think, yeah, I was like, this wasn't like that before. So I just couldn't get things to align properly in the PCB editor. And then there was some, and then other people couldn't reproduce that. There was a whole discussion on the Fediverse where people like, what the hell are you talking about? It works for me. If you move something, and I always had like X, Y coordinates, like some 10.002778, like all these floating point numbers. And everything was kind of janky, and I spent a lot of time manually trying to align parts until I found that there was like a setting that it was only happening to me because I use Wayland, and it didn't happen on X or Windows. So there was a setting that was like warp the pointer, warp the mouse cursor when you, I don't know. So I had to uncheck that, and then it was fine. But for months, I didn't know that. And yeah, so the lesson was ask people earlier. So if something is weird, yeah.
Good morning. How difficult had it been to create a hardware platform here where you can get all the chips also in low quantities, and certain parts, from my experience, are only available to the big manufacturer of computers. So how did you manage that?
Okay. So it differs a lot between manufacturers. So we started out with NXP stuff, and they had like the longest lead times ever, like year or so, half year to like, that was really hard to deal with. And now we switched. So we were like, okay, we can't survive like that. Like we can't always be at the whim of those lead times. We need to be much more flexible. So we switched to, like, we introduced a lot more CPU module options so that we could always offer something that was available in the market, and that we adapt things that were already there, like CM4 form factor stuff. And for example, with Rockchip modules, the lead times are like, okay, 3 to 4 weeks. Yeah. And so, yeah, we just, we switch. We switch to a different manufacturer because we don't want to be bound to these lead times. Then everybody will be very like unhappy in the crowd. Like we do a crowdfunding, and then like, yeah, we ordered those chips. We're still waiting for them half a year later. Sorry, everyone. So this can't work so we can't work with these kind of industrial automotive parts anymore.
Thanks for the talk, first off. And on a related note, can you speak about the economic viability of doing a project like this? Because you're competing with people building millions of units, and I guess you're in the...
Yes. So I would say we are on a long, hard road to profitability. And we have figured out it works better if, like, this is a very new thing, so it works better if we do crowdfunding. Like, ideally, at the moment, we have to do a crowdfunding, like a new project, a new release every year. We had a long break between Reform and Pocket Reform, and that made us nearly run out of cash. So I took a credit because we don't make enough just in the online shop to sustain us. So we have this kind of hybrid model where we have regular sales in the shop, and they are substantial, but we have a lot of personal costs even for a small team. So like our monthly burn rate is around 20,000 euro or something. So, and our margins are around 30%. So we need around 60,000 euro income per month to make it work. And it works if we have a campaign and our own sales in parallel, and it kind of works kind of nicely with Crowd Supply, which is now owned by Mauser, as you might know. So, and they kind of serve more the American market, and we serve more of the European market with our stuff. It's like direct sales, basically. But it is hard. It is really hard. Like, I can't just say, yeah, do this kind of business, because, yeah, it is not easy. I mean, like if you want to have a life-work balance. If you like to work all the time, then it's fine. But yeah, so I think we're getting there slowly over the, like, we still need a few years of patience, but getting there. Yeah, already with Pocket, it's getting a lot better. And I think with the Next, because it will be more like, it will be more acceptable for more people, we have a better chance of selling more.
Yeah, first I want to thank you on behalf of the Amiga community for doing the ZZ9000. It's an awesome piece of tech, and yeah, I guess it's maybe something that runs your shop quite well, because I know a lot of people who bought it, myself included. I have already 2 or 3. So my question is, is it maybe an idea, or are you planning on doing more stuff for retro computing? Yes. Because you know, all these old fat tarts like me, we have a lot of money to spend, and and buying useless for life things. But yeah, so it's an awesome piece of kit. But there's always the question: is there coming more, or is it still supported? I see a lot of people who are trying to get something to run on it. So the sources are already awesome, but you know, these people often don't know how to help themselves. So maybe a bit of a push for the community would be awesome. Thank you.
Thank you very much. Appreciate it. So ZZ9000 is the graphics and network and so on card for Amigas. You say it's kind of like a useless hobby or what? I don't think at all, because it enables you to use computers longer that are around since like 1989 or something. And it is also, it kind of fits in our philosophy of avoiding waste and making things last longer. And I think retro computer people kind of understand that on a maybe subconscious level at least. And yeah, I was a bit burned out by Amiga stuff, but I really want to do something for the Amiga 1200. But this whole laptop business has tied up a lot of my time at the moment. I regret that, but I also don't regret it. Like, at the same time, you understand. But yeah, I guess at some point we need more people who can use KiCad very well. And work with them.
So thanks for your talk. You've mentioned you're serving the European market and the American market. Now you have like a modular design. How do you handle the whole certification, EMC compliance stuff? Do you have some concept for that, or is it just working out somehow?
Well, maybe we can go into detail on that whole stuff outside of this talk. But yeah, in general, I mean, we take some risks, but in general, we do the CE, and for example, on Pocket Reform, we have a Wi-Fi module that is kind of FCC pre-certified, and before, so we use I forgot how it's called, but like component FCC ID for it that was okay for Mauser. We don't sell ourselves in the US. We have a contract, like we signed something with Mauser that we have to be responsible legally for the stuff, like if someone sues them or whatever, but so far it's nice. And we have in the past avoided to put radio technology in the devices at all. It was more like, okay, you can buy a Wi-Fi card separately that has its own separate like CE, FCC, and so on, and then you're kind of responsible if you put it in the device, that you combine these things. So this now it will be the first time that I have to design like a Wi-Fi card module thing myself for the Next. So we have to go then through the whole like more involved process for the first time. But yeah, the reform has been to EMC lab in Berlin. That I had a friend working at one, so I got a better rate back then. Sadly, he doesn't work there anymore. So we're also like, we have a lab in China. But yeah, it's, as you probably know, in general, very expensive and risky thing. Yeah. So I don't have any like great tips or something for that.
Hi, thanks for the talk. I'm curious about the software. Like, what was the most challenging part about different SoCs, like device tree, monitoring the power level, and EDP and all that kind of stuff? Because I have some first-hand experience with that.
Yeah.
So that's a bit of curiosity on my side. Thank you.
Okay, so about difficulties of working with, like getting the software and the kernel and the operating systems to run and so on the different SoCs. So that has been really challenging, and a lot of my work time goes into that, like getting things to run. And the most challenging stuff is around display most of the time, like especially MIPI DSI bring-ups. Weird surprises in the IP that something doesn't work like expected. But what I have discovered is that for most architectures, or most vendors, there is some kind of IRC channel or like a few people, also in companies like Bay Libre, Collabra, and all these kind of Linux specialized companies where people work on kernel drivers, and they have been very helpful when I got stuck. So we kind of look at we try not to just pick a random SoC, but something where we can see some kind of synergy with, like that there is a lot of developer attention or attention by some well-funded project already. Like that's why we chose IMX8M. It was used in like infotainment in airplanes, and it was used by the Libre M5 phone. So we knew that there would be a lot of eyes on that, and we wouldn't be alone. And same with the A311D. It was well supported by Bay Libre. And then now with the Rockchip RK3588, I think there's a lot of people. There's a lot of boards with that chip, and a lot of attention, and great work by Collabra, who wrote a whole new graphics driver stack like Panther, and now Vulkan drivers and so on. So we kind of try to align with these projects always. So yeah, and yeah, a lot of device tree work and driver patching work.
Just a question, a suggestion, maybe you know better. Would it be a good idea to have a customer plug on the main board so somebody can integrate some additional device, special device for himself? I mean, nowadays almost everything can be plugged by USB, but if somebody wants to integrate something into the case?
So facilities for integrating something in the case, what did you have in mind? Like what kind of? Okay, so that would work with USB, I guess. So, and on the Pocket Reform, we have, for example, I2C part, like with Quick standard. We will also keep that around, so you can chain like sensors and stuff. Someone has just integrated accelerometers and Pocket Reform that way, that they could just buy off the shelf. And yeah, there's PCI Express on M2. There's a now there's a new part on the RK3588 module that is like SDIO, USB, and UART in one. That is meant for Wi-Fi, Bluetooth, but you can also use it for something else.
Okay, thank you very much, Lukas.
Thank you.